All right, now we're going to look at section 5.3, properties of logarithms. So as I recall, we just got done talking about the graphing of logs, and we talked about these different items that causes transformations, and you worked on a couple questions related to it. Now, we also talked about some properties before. If I go back to my notes from things, we talked about this property, for example. Now, there's a lot of different types of properties, that we look at. For example, log of, log base 10 right here. Log is understood to be log base 10. ln is log base e. So again, those are properties. But now we're going to talk about properties like the product property of logs and the quotient property of logs, as well as the power of power, or the power rule of logs. These allow us to generate manipulation of the logarithmic power. You see, so we have the power rule, the quotient rule, and the product rule. So there's different types of things that we can go ahead and learn about these. Now, the idea with the power rule, all right, is that you can go ahead and, or not the power rule, but this is the product rule, is that you can split it up and what's called expand. And that's, you'll even see the word and see this expand the logarithmic function. So if we take a look with the same base of 11 on a product of 6 times 5, we can split it up to be just where with multiplication it's addition. So we can go ahead and break up the 6 and the 5 with this. And now imagine for just a second, this was 30. You can make this become 6 times 5 and then break it up. All right. Imagine if it was 22. You can split it up to 11 and 2 and then do this property and simplify further. And in this case, you can't simplify anything further in this, so you just leave it as such. All right. And there's nothing more we can do with it. But like this one now here, we can go ahead and just take it and do log base 14 with the 15, and then just say plus log base 14 of y. So it's really, really fast, okay? There's nothing really to it. Now, there's sometimes when you do this splitting up, though, that it's like, all right, well, we know that this is log base 10, really, but then we can go ahead and do the splitting up part, and that's 4 zeros there. And we can get the following. All right, but then we notice something about this. Well, we know that this is the same thing as writing down log base 10, which is understood to be common log of 10 to the 4th power plus log t. Which in that case, then we can go ahead and simplify this to 4 plus log base t. Or, yeah, not base t, but log of t. And that's what we're going to look for an answer there. All right, so the property that we were talking about earlier, and that was, of course, this one right here, okay? Understanding this, we get into the use of such property in simplifying things, okay? So it's a matter of remembering these properties that we talked about before. And it's just a matter, like I said before, it's about the matching game, making them where these match, all right? So then when you look at this problem right here, we can see that this is going to be split up into 2 parts. And we understood this to be 1 from an earlier property, right? So we talked about that. Log base e is equal to 1. Ln of e equals 1. And I don't know if I wrote that. I basically put it here. Oh, I did kind of almost put it here, but I'm going to give it to you now. I should have given it a little bit here. So log base e is equal to 1, because it's the same thing as this property right here. It's whatever the value is here becomes it. And when we don't have a number there, we understand it to be 1. So that's why it is the same thing. This is like x and x. This is the same thing. So I did kind of go over it, and I just want to make sure that we're we understand that this is going to equal 1. So we get this, and that'll be 1 plus ln of x. Okay, so we want to make sure we're using those properties, because we're just not going to just separate them now. We're going to have to simplify our expansion. Okay, so this follows the same thing. Now, this, however, is quotient rule because it's got division going on here. So because it's division, we're going to split this up where we put the log of t with a minus whatever is in the denominator. It's log of 100, but we know that this is kind of like this a little bit, where we're going to simplify this, and this would understand it to be at 10 to the second power. Therefore, this is going to become log base, or not log base, but log of t minus, and then because these match, it's going to become 2, and I'm not going to rewrite it out. I'm just going to put minus 2. All right, I'm saving myself a little bit of time. All right. Now you probably sit there and think to yourself, does it matter if I put the parentheses or not? I say try it, see what happens. Sometimes it gets confused with are you trying to put LOGT or are you trying to put log of t? So that's why the parentheses. So, but I always say try it and see what happens. So matter of fact, because I'm me, I'll try it right now. Watch log t, and you know what? It doesn't let me put the t in there. That's awesome. So it says use algebraic expressions, and so we need to put in the parentheses in order to put the t in there. That's kind of interesting. All right, so you can't move forward without the parentheses. All right, so anyway, it has to have the t, has to have the value of, or the parentheses. So anyway, now moving on to my next page. I'm using up this paper, right? Trying to blaze through and try to use as much paper as possible. Save a tree, right? So there's nothing changed or different about this. So we're looking at log of x with log, and then minus log. Oh, by the way, there's a 12 there. So it's log 12 of 5. All right. So that's the answer we're looking for there. I mean, these move very quickly. All right. And nothing different here. It'd be log. I could put just log 8 minus log 3. But they have like where it's a 10 there. And you know what? Try it. I mean, I love curiosity gets the better of me. I mean, they should accept this answer. Log 8 minus log 3. And they accepted it. Because it's the same thing. That's using that property that we talked about earlier. It's common log. If they didn't accept this, I'd kind of be like, man, disappointed in the setup of it, right? All right. Now we get into a little bit more here. So now we're going to have to do log. Now it's no base, so it's common log. Log 18 plus log y. Now why I did that? Because there's multiplication there, right? And then I'm going to say minus log of 7. And that's the answer we're looking for there. All right, so what I did was I brought the first one, the numerator down, and I split it on top of then just putting the minus at the end. Don't make sure that you put this one, it goes like this with the plus sign, this, and then the minus that, okay? So now we get into what's called the power rule. So anytime you're dealing with power, what we have to do is drop the power first before moving forward. So what this does is it comes and moves to the front. And then that leaves us with then 8 log base 10 of t, or simply just 8 log t. All right, that's called the power rule. Okay. And you can do that at will. Now they're starting to mix all these things together, and it starts to create more stuff going on. So you have log 15 of 1, which by the way is 0. All right. And then minus, and then you have this 1/6. Why is that? It's because isn't t raised to the 1/6 power because of the index being 6? So I have then this. So my answer is just this, because why? This is 0. So watch what the answer becomes. All right. Now, the power rule is really easy. Just bring it in front. But you need to remember that the 6th root of t is the same thing. And if you can't see this, I mean, I have to write it down. That's a shame. I'll write it down, but geez, you better start remembering this a little bit more. That this is the same thing as this. All right. Remembering that the index of the radical becomes the denominator of the exponential power. All right. Now, this is just, again, continuously expanding. It's getting more and more, but it's not any more difficult. So this is, look at this. I'm automatically going to put 2 minus log of x to the 1/3 power. Okay. Oh, and by the way, that 1/3 power comes to the front. So I'm going to move that out of there and put it right in front. So there's my answer. All right. Pretty easy. Now we're looking at where it's log, or now it's ln, but ln of x to the 3rd, but the 3rd is going to come down, so I'm going to bring it down to the front. Then it's going to become minus, and then what I can do is I can group all of the, oh no, hold on, that's plus. And then, I'm sorry, my mind went somewhere else. This is the first part, right? And then it's going to be plus, and then I'm breaking up this part. Now, here's the thing, is that when I look at this, see, this is from an intermediate algebra lesson, is that I'm looking at this as the same thing as me writing it this way. This is understood to be 2. 2 goes into 18 9 times. So I'm looking at that as y to 9. And then this is z, and 2 does not go into 15. So I'm just going to go ahead and put down 2 or 15 halves, just for time being. Now I'm going to go ahead and split this up into being now 9 ln of y. See, because I brought this down, and then I'm going to put minus, and then I'm going to put the 15 halves, and then the ln of z, and leave it like that. Now I could take and do away with this, the parentheses, all right, and I don't really need those parentheses, okay, but it doesn't hurt, because there's one big ass grouping. Whoops, excuse me, I used a bad word, but there's a big grouping there. And then we can go ahead and erase this, because it doesn't make a difference to our impacted change of our values. So we're going to leave it as that and see that this is what the answer is. So 3 ln x, and then the 9 ln y, and then the negative 15 over 2 ln z. All right, and by the way, all those have to be in parentheses. All right. So then you keep on, well, this one's the same, almost identical to this one. This one's almost identical. So I'm just going to go ahead and write it down as 10 ln x, and then it's 1/2, so it's going to be 2 goes into 8 4 times, so it's going to be plus 4 ln y, and then minus, and then it's going to be 2, so it's going to be 11 halves ln of z. All right, that one almost identical to what we had up here. All right. All right. There's not much going on with the difference in the properties there. So now you're looking at the same concept here. You're going to have just the log of 8/3 for your base. The 12 is going to come down, so it's going to be 12 log 8/3 of x, and then it's plus 1/3 log base 8/3, and then oh, actually it's not 1/3, it's actually 2/3, because the 3 goes into the 2 only 2/3 times. You can't do it, so that's going to be 2/3. So that's why your answer would be plus 2/3 ln base 8/3 of y. So what I just verbalized is the answer. All right, so I just verbalized that entire answer. So it gets to where you're expanding. Now you probably start to get intimidated by this. Don't let your fear start getting in your way of just common breakups, right? So this is going to be log, and if you can't do it mentally like I'm doing it mentally, just go ahead and write it all down. Just go ahead and do this, right? And that's 2. You got x to the 12th, and then you have a grouping down there on the bottom there. So what we do is put a minus sign and then put a parentheses, since there's more than one item down there. So then now we go ahead and do log base 2 of z to the 1/2 power, and then you have plus log base 2 of 14 to the 1/2 power. Okay, now you can go ahead and do the power rule. See, so now I'm going to get 16 log 2 of w plus 12 log 2 of x, and I'm going to get minus 1/2 of log 2 of z minus, I did the distributive property, right? Minus, and then it's we have, what is this? This is okay. Oh, hold on, wait a second. I just screwed that up. It's not, that is not true with what I just put down here. This is not true. That's why I'm like, what is going on here? This is goofy. So that is not true. I gotta erase this. This is erased. I don't know what I was thinking. That is not right. What was I thinking? Anyway, since this is one grouping, we got to put it in parentheses like this. That's the way to do it. I forgot, it's a binomial. So you can't just split it up like that. That was very ignorant of me doing that. I made a mistake. Now I go ahead and do this. This is all the truth. I mean, all that remains the truth. But this is now 1/2 of, now this, there's only one little tiny mistake, but it's a big one, and I needed to correct it. And then it becomes z plus 14. Okay, so then the 1/2 drops down. This would have been a critical mistake. Don't split them up like that. That wouldn't have been effective in using the proper techniques. There's no such thing, additional logarithmic property or anything like that. So watch this. Okay, I got the right answer. I just was about to make a mistake, so I wanted to take that mistake away. All right, I'm glad I caught that before. I'm like, this doesn't feel right. All right, now you go into using properties again. Now we're condensing them, so you're going in reverse. So you're slamming on brakes and going in reverse. So if you're condensing it, all right, you're looking at the idea that there's multiplication going on here. So it's just going to be log base 15, and then you can literally just write it out as 25 times 9 if you want, or you can physically multiply it out in your calculator. I'm curious as whether or not they'll accept that. So I'm going to put it in as that. So 15 before I look at the answer, and then open parenthesis 25 times times 9. Okay, now it looks like they want you to multiply it out. Okay, so I needed to go ahead and show you that they want you to physically multiply it out. That kind of, I mean, it's not a big deal. I mean, I just wanted to see if they would accept it. So do 25 times 9. Does it say that? The solution should be single logarithm with a coefficient of 1. Okay, so I guess that's where it's saying that it wants a single. It doesn't want to have that double. Although they gave you questions like that. So it'd be 225. All right. What? Oh. What is 15? Look at 15 raised to the second power. What does that equal? All right, that's great. I love it. Okay. So they automatically wanted you to condense it and then go ahead and simplify it. So I didn't, in my mind, all I was trying to do is prove the stinking thing, just multiply. They shouldn't have done that in the first one. I wasn't expecting them to do that. So this one is just 2. All right, now you look at this next one, and they go ahead and do log 5, and then it's 100 minus, so it's going to be 100 divided by 4, all right, which is 25. Now that I know that they're being a little jerky here, I'm going to make sure. I wasn't even paying attention to that they were doing that, giving us numbers that were like that. So we have this, and so the answer is again 2. Come on, give us something different. All right, now this one is 2 times 9, which is 18, and that one we can't do anything with. So this one is 18, and we can't do anything with that one because it doesn't break down. Now this one, now take note of how the parentheses are around it, where they have a 6. Okay. Now what we could do is distribute it out the 6 to both things, right? So you have this log 4, 2, and then you have plus 6 log log base 4 of A, and then you have minus log 4, 6. Okay, so now this comes up, so we're going to get log 4 of 2 to the 6 times A to the 6, and then all of this is going to be over, whoops, all this is going to be over 6. So that's what our answer is. It's going to be log 4. 2 to the 6 is 64. So it's 64A to the 6 all over 6. All right. Now, interestingly enough, they go ahead and combine it. They just do it the way they did it there. Mine is expanded, so I'm curious now as to whether or not that would be acceptable answer, which it should be. But I always like to show my students that, hey, I can get it wrong just like you can, but I'm going to learn from what the parameters are of this particular system. That's what I want to know. What is the tolerational value? Because I know this is equivalent, but do they want it like that? We'll see. Here we have it. And it looks like they did accept it. Okay, that's what I wanted to hear or see. Oh, and I was totally off the recording. Sorry. I hate when I do that. I don't realize the book is falling off the screen. More the camera. Hello. All right, now here, this one, again, we're going to raise the powers away, bring the powers back up. So we're going to do log of 3 to the second power. And then since we're plusing it, it's going to be multiplied against x to the 7th power. And the easy way of writing that then would just be log of, and then just raise it, 9x to the 7th. That's how we'd write it. All right. And that is the answer they gave. So pretty straightforward. It's using those properties. All right. This one says to condense. And all this one wants us to do is bring the 9 back up. So then that one's ridiculously easy. All right. They should start with kind of questions like that. I mean, I don't understand. Okay. Now you have two things that have minus signs. Anytime it has minus signs, put it underneath. So I'm going to go ahead and start this out by just doing log, and it's base 4 already. I mean, it's not base 4. I mean, log, common log. It's log base 10. So all I'm going to do is go ahead and open parentheses and put 4 to the 4th power times y to the 2nd, all divided by 9 times b. And because both of them have negative signs, I know that they're both in the denominator part of my condensed form. So I can put my answer as then simplified version. This is 256. If you just take a calculator and multiply it all out. So we're going to go ahead and do 256 y to the 2nd, all divided by 9b. All right. At least I got something right, huh? And then why did I missed the 3? Darn it. Missed the 3. I didn't get it right. See, that's one thing. It's about you see the 3 right here? I just didn't bring it up. So I got that one wrong. Chalk. Got that one wrong. Okay. So what? All right. It happens. But just all that does is prove to me that I better pay attention when I'm taking my test and doing my assignments. This is your assignment. This is not my assignment. This just tells me that you have to pay attention for yourself, huh? All right, now looking at this one, they're both base 5, so this one's going to, and they're both, it's plus sign, so it's multiplication, so it's going to be log 5 of 7 times x to the 7th power. All right, that one's easy. All right, and I got that one right. I didn't miss anything. But I wouldn't miss anything either here. I'm a little upset that I missed the 3. Because you see how simple that was. Man, I don't like it when I miss something. I'm not missing anything anymore. Yeah, right. All right, now with this one, condensing, we're going to go ahead and do this, where we take log of, and then it's all common log. That's good. Then we have z to the 8th, and then y to the 10th. And then it's going to be all divided by, and then it's going to be w plus 20 to the 1/5 power, or I could simply just do this. I could take it to the 1/5 power. It won't be wrong with that. But since we know that this is the 5th root of, I'm going to just go ahead and put 5 right here, and it's simple. It makes it real simple. And then, of course, I close my parentheses. So that's my answer. All right. So condensing, opposite of expansion. And you get the feel for what they're looking for when you do enough of these problems. Okay, I've done a lot of this for you guys. I'm going to let you guys go ahead and, oh yeah, now this is the change of base formula. All it is again, because in case some of you don't have your calculators, this is the change where the change base formula is introduced to you, then all you got to do is go ahead and take the log of what you're taking the log of, not the log of the base, but the log of what you're taking the log of, which is 6, divided by the log of the base. Now, I hope you understand the base is the smaller number. It's a sub-leveled number. So that's when you're going to take log of 15, and then you get this. Now, that's why you're going to put log. Now, they have log base 2 because it's asking you to take and put your bases to. It does not matter what the base is. You can put base 30,000 and it doesn't make a difference. As long as they're the same, it's going to be how you operate this. Now, approximately equal to, and then it wants us to round it off to 4 decimal places. So that's 0.6616. All right. And that's where it doesn't matter what the bases are. They're purposely putting in so you don't understand what you're doing here. They're trying to throw you off. Do you understand? It doesn't matter. You can go ahead and change or keep log of anything. I'm going to show you something here. That's an N, by the way. And they're saying that the log of N, what is it? Log of that over the yeah. Put the N here, put the M here. That's what they're saying. Now you can go ahead and do this. Any other log number, as long as they're the same, it don't make a difference. That's a property that you'll learn in doing this. Okay. So that's the property, and I'm, of course, keeping it simple for you. They say base 3, so it's going to be, all right, convert this. It'd be log base E, which is ridiculous. You don't have to do that. That would be like saying ln then, the same difference. But log ln E of 9 over log base E of what the base is. And that would be your what you would put into your system. And again, it would be ln E, because we've already talked about that, or ln 9 and ln 3. Same thing, right? And by the way, they will accept log base E of 9 over log base E of 3. And then you punch it in your calculator. And watch this. It doesn't matter about if I take it with natural or common log. It doesn't make a difference. And I'm going to prove that by showing it on the calculator here right now. I'm going to do it with log, right? And then I'm going to go ahead and do it with ln. Same exact answer. Now, this is what you can't do, though. Watch this. Log of 9 and then divided by ln of 3. You can't do that. That is not right. That's not going to get you the right answer, because you're changing that base then. You're changing it from common log to natural log. And natural log is a base E and common log is a base 10. So there's 2 different bases. You can't operate on 2 different bases for your change base formula. Okay? So the answer is 2. And then of course then again you can, because it's base 10, you don't even need then to put the log 10 or the base number. So that's why you get into this. All right? Log 10 over log 19, and you can punch in your calculator. All right? Now that's for those of you who do not have this. Math A. And then you can just go ahead and evaluate any of these. Let me do the last one, 19. All right. Oh, and then we're taking 10. And let's see what that comes up with. Looks like it comes up with exactly the same answer as that. So that formula, the change-based formula, is for those of you with an older operating system, like a TI-83 version less than this. It's really, really slow and doesn't have really a lot of good functionality to it. I've updated to the latest operating system on this one. And that is the last couple of problems they have for you, okay? Using the change base formula, you can't even evaluate this. They want base 2, so it's going to be log base 2 of negative 6y, and then all divided by log base 2 of 6. And that's all they want you to do. Okay? By the way, you should have parentheses, so you can't put it in without the parentheses. All right. And that's it. That's all I got to say about that. I'll show you the remaining answers here. All right, that's for what, 5? Yeah, 5-3. I'm hoping you're enjoying logs. I mean, they're not that bad. I mean, this is pretty. It's just moving pieces. That's all it is. You got to learn properties. That's the problem. Can't remember all the properties, then you're kind of in a world of hurt.